Okay, this is going to be a video, a second actually attempt at a video for question number 11 on your midterm exam. I'm using a little bit different technology. I'm using a Gene video to make this video. Okay, so if you remember, what you see on the screen is this is the albumcells.sav file. And what we're going to be doing, the first thing we're going to do is we're going to run a correlation matrix on all four variables in the file. Remember, cells is going to be our dependent variable, and the amount of money spent on advertising is going to be, that's the first column, that is a predictive variable, in amount of airtime associated with oops, looks like my screen went blank. Okay, amount of airtime associated with the album is going to be another predictor, and then the attractiveness of the band is a third predictor. So we go up to analyze. Let's see here, having some issues. Okay, let's try that again. So we'll do analyze. We're going to go to correlate, and we're going to click on bivariate. And then if you remember, you can hold down the shift and go to the bottom and move all the variables in at the same time, or you can move them in one at a time. We're going to click OK. Now remember how to read the correlation matrix. So for the advertising budget, you can go across and see we have an R value of 0.578 in relationship to album cells. And if you look right below that, 0.000, that's the probability that that R value could have occurred by accident. So it's statistically significant because it's much less than 0.05. Number of airplays, the correlation between advertising budget to the number of airplays is 0.102. But what we're most interested in is, and if you look, I say explain the results in relation to whether three possible predictors are significantly different from the dependent variable cells. So we know that advertising budget is a significant predictor. If you go to number of plays on the radio, it's slightly higher R value of 0.599, and that's significant, much less than 0.05, and the attractiveness of the band, 0.326, was also significant, even though it was lower. Okay, so that's the correlation matrix. The next thing you do is we're going to run an inter-method regression, which is fairly new to you guys, but we've done it a couple times now in class. So you go to Analyze, we go to Regression, and we're going to go to Linear. Now remember, regression, we think about it a little differently than correlation because we're trying to see, it's basically an equation that allows us to predict one variable from one or more other variables. In this case, it's going to be more than one predictor. Because I ask you to run inter-method regression with two predictor variables of your choice, the ones that you think are most appropriate. And obviously, because two of them were higher than the third in terms of R values, I would go with those. Number of plays on radio and advertising budget would be your independent variables. And you notice it's already set on inter-method, so you don't have to change that. The dependent variable is album cells. And that's really all you need to do for this particular question. Oh, with one other exception. Click on Save and make sure you save out the unstandardized predicted values. So those are going to be the values that are predicted based on the equation, which is going to be y equals b sub 0 plus b1, x1, b2, x2, with b1 being advertising budget and b2 being attractiveness of the band. That order might be switched. So we'll click OK, and then we'll run our regression. And what you need to do is you'll cut and paste both the correlation matrix and the results from regression into Word and explain what the output is telling us. So the first thing you see is a model summary table, and that tells you that you see a 0.793 R for the two predictor variables together, and 0.629 is telling us basically that 62.9% of the variation, that's called R square, 62.9% of the variation that you're seeing in the album cells can be attributed to those two predictor variables. And then in your NOVA table, that tells you that the amount of variation that can be explained through the regression through those two variables is very significant. It's much less than that F value is very large, and the SIG is obviously much less than 0.05. And then the coefficient table really tells us about how each of the predictors are related to the cell's data. So you can see that the ones we're most interested in are what they call the standardized coefficients. So for every 0.5, for every 1 unit change in the predictor variable, you have 0.523 units of change in the outcome variable, which is sales. The same in terms of number of plays. For every 1 unit change in number of plays, you have 0.546 units of change in the cells. So they're pretty much about the same in terms of how predictive they are, with the number of plays on radio being slightly more predictive. And both are statistically significant compared to a estimate or a predicted value of 0 for the beta, which would be no predictability at all. So that's pretty much it. Let's see what else I say. Oh, the last thing we want to do is run a scatter plot, looking at the actual data compared to the predicted data. So we'll go to Graphs, Chart Builder. Okay, we'll click on Scatter. We'll just do the simple scatter. And then we're going to put album cells is going to be in the y-axis. And then unstandardized predicted values is going to be on our x-axis. And that's all we need. Click OK. Okay, we talked about this in class. I'll double click on it. I'm going to add a regression line. Try to add a regression line. Here we go, a regression line. It'll default to the linear. Okay. And then you're going to need to explain the plot. And you can see basically that if the model was perfectly predictive, it would just be a single straight line. But we do have actually a pretty tight line, so we know that that model is fairly predictive, which means that most of the time what you observe versus the line itself represents what you predicted. So you can see all these dots right around the line. For all of those observations, the model was very predictive. And for some, it was less predictive, but in general, it was headed in the right direction. So that's pretty much what you need to know. You can see the R-square is 0.629, which we saw earlier. Okay. All right, we'll go ahead and stop the video.